Dynamic Demand Challenge is a challenge prize run by Nesta in partnership with the National Physical Laboratory and Climate Care. The intention was to stimulate innovation in demand-side response for households and small businesses and hopefully reduce carbon emissions in the process.
My name's Joe Warren from PowerVault, and we entered our Dynamic Demand energy storage device into the Nesta Challenge. Effectively, what the device does is stores energy during the day when customers are generating a lot of energy from their solar PV panels, and it gives that energy back to them in the evening, and that saves them money. So at the moment we've manufactured 10 devices, and we're currently rolling them out to homes in a trial that we're running, and we're looking forward to bringing this product to market later in 2014.
Our take on demand response was starting with a campaigning element, whereby we said, what if you could automate behaviour response, behaviour change in homes? So rather than taking a very high-tech approach with gadgets that switch on and off automatically through from the national grid, we thought, what if you could just ask people to save energy at specific times of the day, specifically the evening peak? So what we've come up with is a simple fridge magnet. It's radio controlled, there's no infrastructure required in the home. It uses a very low powered display, and it sits on the fridge, and the homeowner, it flashes and shows them and asks them to save energy, switch things off for 15 to 20 minutes each evening at the most important times. And there's also a community element built into it, where you press the button and it shows how many other people in your local neighbourhood have responded. And so this is a project that we're rolling out in 50 homes with Western Power distribution over the next 6 months. Thank you.
Okay, so I'm Peter Boait from the Powershaper team. And what we want to do is to bring smart control to the 2.5 million homes that have electrical heating. We want to control their heating better so that it gives them more comfort and saves them energy. And those 2.5 million homes are a bit of a neglected community. 80% of them have storage heaters. Anyone who's ever lived in a storage heater home or flat knows how frustrating they are to control. Cook you overnight, leave you cold in the evening. So we can do a lot better than that. We can save the money at the same time, and we can bring them into a dynamic demand community, help solve the problems of the grid that this competition was set out to achieve. And there are two bits to the technology. First of all, there's that which is inside the home, the smart control, regulating the temperature correctly so that people aren't overheated and don't end up cold and then having to put on fan heaters. So that in itself saves carbon and energy, but also we want to take those appliances and manage their demand so that it integrates with the grid. When the wind farms on the North Sea are blowing, we want to soak up that energy, and it will be cheap, it'll be good for the grid, and it'll give low-cost energy to these consumers. And to do that, we're using a signalling technique which is complementary to the 50 Hertz frequency of the grid, which we heard out earlier in the evening. Operates on a daily cycle, just like your heating. It takes a long time to heat your room up. Things cool down slowly, so it has to operate on a longer cycle than fridges. But our signalling technique allows millions of homes to participate, including the heat pumps that are now being incentivised by government subsidies. You can get £700 a year to put in a heat pump. Lots of people are going to be doing that. We need to make those heat pumps grid friendly so that our existing infrastructure can use them. And so with a combination of these two techniques, we think we can make life a lot better for electrically heated homes. And what we've been bringing here is essentially a piece of academic research at De Montfort University that was completed just over a year ago. And what this competition has done is kind of accelerate the process working out a business model. We wouldn't have done that if we hadn't had the benefit of the tuition from the guys from Imperial and elsewhere, and the sort of pressure which this competition has generated. So they've incentivised us to develop a business model which we hope to take forward.